Hi class, this is Professor Smith. I'll be working on Final Exam Review Part 2, question number 9. We're asked to find the partial fraction decomposition. The first step that we want to do is factor the denominator. I notice I have an x cubed and an x, so since x occurs in each term, I will factor out that lowest power of x. And so I'll open up math type to capture. So as we factor the denominator, we're left with x times x squared plus 2. And because 2 is not a perfect square, then we know that this is what's called a quadratic that can't be factored anymore. Sometimes we call it prime. Another term for it is irreducible. If it were x squared minus 4, then we could factor x minus 2, x plus 2. But because it's added to a constant, then we know that it's irreducible. There's no factors of 2 that add up to 0. Well, the only factors of 2 are 1 and 2 and -1 and -2, and neither of those add to 0. All right, so now that we have it factored, it turns out there's a rule. Now that we have it factored, it turns out there's a rule for finding out the partial fraction decomposition. So let's open up Preview so that you can see the rule. So I'm looking at part 2 of the rule. It says, suppose that the denominator contains an irreducible quadratic factor of the form ax squared plus bx plus c, then the partial fraction decomposition will contain a term of the form bx plus c over that irreducible quadratic. So it turns out whenever you have a quadratic that can't be factored any further, then you want to make sure that instead of having b over that denominator, you have bx plus c over that denominator. The first part of the rule we've already seen before, that if we have a linear factor, it's just a over that linear factor. So distinct linear factors, that's how we did the very first one, problem number 7 on the sample exam. So now we'll rewrite our rational expression using the rule that we just learned. So 5x plus 8 over the factored x times the quantity x squared plus 2 will be written as a over that linear factor plus bx plus c over that irreducible quadratic factor. Then the next thing we're going to do is multiply by the LCD so that we can eliminate the denominators. So I've multiplied each term on the right by x times x squared plus 2 using the distributive property, and on the left I've multiplied x times the quantity x squared plus 2. The denominator on the left will cancel x squared plus 2 and the x, leaving me with just the 5x plus 8. And the denominator on the right, for the first term, the x will cancel with the x, just leaving me with a times the quantity x squared plus 2. And then the second factor, the quadratic one that's irreducible, it will cancel, leaving me with x times the quantity bx plus c. It's very important that because we have a numerator of bx plus c, that when we multiply by that x, that we use parentheses. So again, that denominator totally cancels out on the left-hand side, so it's gone, 5x plus 8. And then we have a times x squared plus 2, and then x times bx plus c. And again, remember to include those parentheses. As we multiply through by a and x, we'll have the following simplification. We have 5x plus 8 equals a times x squared plus 2, and then x times bx plus c, distributing. On the right, a times x squared gives us ax squared, a times 2 gives us 2a, x times bx gives us bx squared, x times c gives us cx. Then what I've done is grouped the like terms together. I have an ax squared and a bx squared, so they're grouped together. There's only one lone cx and only one lone constant, just 2a. So when I factor out the x squared, that leaves me with a plus b times x squared, and then cx plus d. On the left-hand side, I notice there's no x squared term, so I could rewrite the left-hand side as 0x squared plus 5x plus 8. And you say, well, why would you do that? Well, because I have an x squared term on the right, and I want to equate those coefficients. So here I have a 0x squared, which is equivalent, 0x squared plus 5x plus 8, which is equivalent to 5x plus 8. And so now I can equate the coefficients. So 0 must equal the coefficient of x squared on the right, which is a plus b. 5 must equal the coefficient of x on the right, which is c. And then 8 must equal the constant 2a. So we have a system of 3 equations and 3 unknowns. The first equation is 0 equal to a plus b. The second is 5 equal to c. And the third is 8 equal to 2a. Solving for a in the last equation by dividing both sides by 4, we get a equals 4. And then using that first equation, 0 equal a plus b, I can now plug in 4 for a and solve for b. Subtracting a 4 from both sides, I get negative 4. So a is 4, b is negative 4, and c was equal to 5. So we're going to rewrite our rational expression with the values a of 4, b equal to opposite of 4, and c equal to 5. So that 5x plus 8 over x times the factor x squared plus 2. And now we replace that a with 4, b with negative 4, and c with 5. And we have 4 over x plus negative 4x plus 5. I didn't say this in the last 2 examples. Well, I think the last example, I think they did in the first. You can check it to make sure that it's correct by getting a common denominator. So for example, with this expression here, if we multiply top and bottom by x squared plus 2, and then multiply the second one by x over x, we'll have a common denominator. So it's almost like cross multiplying. If I take 4 times x squared plus 2 times and then negative 4x times x all over this denominator, it should equal the left-hand side. So let's do that. 4x squared plus 4 times 2, so that's 4x squared, and 4 times 2 is 8. So 4x squared plus 8. X times negative 4x is negative 4x squared plus 5x. So the 4x squared and the negative 4x squared is going to cancel, leaving me with just the 5x and the 8 all over x times x squared plus 2. So this one actually is easier to check to see that indeed that we have the correct answer. So let's go ahead and substitute that in on Alex. So it's going to be 4 over x plus minus 4 x plus 5 all over x squared plus 2. You see how weird that was, how it had that weird plus minus thing? I don't think it likes putting a negative 4 there for whatever reason. So x squared plus 2. So just ignore the funkiness if it does something like that. Be careful if you put the subtraction symbol here and you say, well, I want to put the subtraction here, then make sure you make both, change the sign of both the values in the numerator. Then negative 4x, negative 5 is plus 5, so then it will line up. All right, so just be careful. It'll take either one, but we'll just go ahead and put back the plus and change this to negative and this to plus. So I hope this movie on partial fraction decomposition was helpful for you.